Hello, everyone, and welcome back to our discussion about the unit circle, in which we have an inscribed hexagon. So here, we try to imagine what if we have a hexagon, but it's what do you call this one, rotated in 30 degrees, whether if it's in counterclockwise or not. So as a result, we will have this one. This is the result. So what we're going to find, wait, hold on. Let me just draw the other lines here that were not shown because it's been covered by the what do you call this one? It's been covered by the shape itself. But anyways, we will find the coordinates of each of the vertices. So there are six, right? We have 1, 2, 3, 4, 5, and 6. But you see here, we're going to find only 4. Because the other two, I think we already knew the coordinates of these two. Can you guess what are these vertices that that has the coordinates in which we discussed it last time? Okay, or basically, can you tell me what are the two vertices that we knew about its coordinates? If you advance study, of course, you would pick anything. But so far, what would it be? So it's these two, of course, okay? So it's these two. These uh these vertices have the coordinates of 0, 1 and 0, -1 respectively. So to give a short what do you call this one? Short information about it. I've discussed this in the first part of the unit circle. Okay? So what if we form a quadrantal angle? So what would be the coordinates? Or what would be the coordinates if our terminal side stop along the y-axis, which is this one, okay? Or on your x-axis. So you will either have the coordinates of 1, 0, -1, 0, 0, 1, or 0, -1. So here on the top, if it's along in the y-axis and it's on the top, so it's 0, 1. And here it's 0, -1. Okay, so that's it. Now, we're going to find the other coordinates. I mean, yeah, coordinates of these vertices. So there's nothing changed here actually, except that we just rotated in 30 degrees. So what does it imply? It implies that this hexagon has still 6 equilateral triangles. Remember that in our last previous video, okay, in a hexagon we have what? We have 6 equilateral triangles, right? So this is the center. So we have 1, then 2, 3, 4, 5, and 6, right? So if you're going to rotate it in 30 degrees, so this would be the result. Okay, hold on. This would be the result. That's it. Okay, so the center, so we will have equilateral triangles here. So 1, 2, 3, 4, 5, 5, and 6. So there are 6 equilateral triangles. And the interior angles do not change. Okay, it's still 60 degrees. Okay, so this is 60 degrees, 60 degrees, 60 degrees, 60 degrees, and so on and so forth. Okay, so on and so forth. Okay, so with that, we can use this as our guide for this case. Okay, so once again, okay, if we're going to imagine, so this is the center. So we have, wait, hold on. So this is the center, which is the origin. So here we will have 1 triangle, 2 triangle, 3 triangles, 4 triangles, 5 triangles and 6 triangles. So 1, 2, 3, 4, 5, and 6. 6 triangles. Okay, let me erase the x-axis. All right, there you go. So 1, 2, 3, 4, 5. So there are 5 triangles. No, 6 triangles, I mean. Okay, but we have the x-axis here, right? So we cut this thing. It's like we cut it into half, right? So here, imagine this way. Imagine it. Let me draw this one once again. Okay. You know what? I should have just put a regular hexagon shape here. You know what I mean? But yeah, let's make it bigger. Okay, let's make it bigger. Okay, there you go. So once again, there are like 6 triangles, right? So equilateral triangles to be particular. Okay, so there you go. Okay, and right, the x-axis here, we have this one. So we have the x-axis here. So remember that the angle here is 60 degrees, right? So what happens if if there's a line that intersect here? So it bisects the angle. That means it cuts the angle into two. So 60 divided by 2, we have 30 degree. And here, the remaining, we have 30 degree. Similarly, we have 30 degree, 30 degree here. Okay? So here, if we have 30 degrees here, then that means the other angle is we have 60 degree. And of course, this is a right angle. So this is also 60 degree, right angle, and this is 60 degree. How did we know that? How did we know that it's 60 degree? Well, it's not only because that each of the vertices are, I mean, each of the how should I say this? Of each of the vertices here are 60 degrees, okay? Just like what we discussed last time. But remember, if we have what do you call this one? If we have 30 and 90 degree, what would be the missing angle? 60 degrees, right? Or in other words, remember about 30 degree, 60, wait, I ruined the moment. 30 degree and 60 degree and 90 degree triangle, right? Remember this one. You get me? Remember this one. Okay? If we do not know the missing value of the angle, but we know that the two angles are 30 and 90, so this is 60 degree, right? If we have 60 and 90 degree as the given angles, but we do not know the missing angle, so this is 30 degree. And lastly, if we have 30, 60, but the one angle here is missing, what will be the missing angle? That would be 90 degree. So they go along together. Okay? So in short, guys, it has the application of 30, 60, 90 degree right triangle. Okay? And now that I visualize it, this one for you, so what happens? So let me erase this one. Okay? What happens that we will have an angle of 30 degrees on other side of the right triangle. So 30 degrees here, 30 degrees here, 30 degrees here. Okay? So what does it mean? So that means these coordinates, this one, 2, 3, 4, these four coordinates have the same numerical value, but the signs will differ. So just like the last time, okay? Let's start with this one on the right side, okay? So let me erase this one. On the right side. Remember, again, in 30, 60, 90, right triangle, wait, let me erase this one, okay, for convenience. Okay, so on the right side, we have this one, right? So here, we will find, to find the, define the coordinates, we will find the x and y coordinates, okay? And this is 30 degrees. And of course, this is 60 degrees and 90 degree. So how to find, okay? So remember that if we have what? A 30, 60, 90 degree triangle, okay? So let's just say you have this triangle, you have the hypotenuse. So We have two versions actually. Having 60 degree as your base angle, or having 30 degrees as your base angle, just like this one. Okay? So it's simple. Okay? So in here on the base, just divide the h by 2, remember last time, and the second longest side, which is the height, h square root of 3 all over 2. This one, on the other hand, will be different. On the base, we will have h square root of 3 all over 2, and on the height, we will have h all over 2. In short, guys, look at the base and the angle adjacent to the base. So here we have 60 degrees, which is formed by the base. So if we have 60 degrees, and then you will find the adjacent side of it, which is this one, it's h all over 2. Okay? If it's 30 degrees, use h square root of 3 all over 2. So here, as you can see, we have 60 degree. So we will use h all over 2. And for 30 degree, you will use h square root of 3 all over 2. Okay? So once again, if it's 60, you will use h all over 2. If it's 30, you will use h square root of 3 all over 2. Okay? So it depends on your adjacent side. Okay? So one more time again, if the angle here is 60 degree, then the adjacent side would be h all over 2. And if you have here 30 degree, the adjacent side of 30 degree would be what? H square root of 3 all over 2. So now you already know. Okay? So now let's have it here. So in here, your hypotenuse is still 1. Okay? It doesn't still change. It's still actually 1. Okay? Makes sense because you see the radius here is here, which is intersecting or intersected at the one of the vertices of the regular polygon, and also intersecting an endpoint on a circle. So it is obviously 1 unit as your radius and as your hypotenuse. So let's find your x coordinates so that we can find the coordinates here. So what would it be? So here, if it's 30 degrees again, you will use h square root of 3 all over 2. So this is 1 times square root of 3 all over 2, which is square root of 3 all over 2. That's it. And here for your y, that's the same thing. So h all over 2, so 1 all over 2, so 1 half. Actually, it's not the same, all right? Forgive me, but I think you get my point here. Like, what would be the formula you will use? Okay? So that means the coordinates here would be what? It would be square root of 3 all over 2 and 1 half. Okay? Square root of 3 all over 2 and 1 half. All right? So that's the same thing on the left, to bottom left, and on bottom right. It's the same in terms of their value. It's still square root of 3 all over 2 and 1 half. They are the same. But the difference, though, is that the signs will alter. So remember that in the first quadrant, we will have both coordinates are positive. On the second quadrant, only the x coordinate is negative. On the third quadrant, both coordinates are negative. And on the last quadrant, on the fourth quadrant, only y coordinate is negative. So that means if numerically speaking, they're the same, but they're in different quadrant. So that means they will change their signs. So just like this, for example, on the left side, which is on the second quadrant. So here, if we have square root of 3 all over 2 and 1 half on the right, here we will have negative square root of 3 all over 2 and positive 1 half. Okay, that's here. Okay, here below, we will have negative square root of 3 all over 2 and negative 1 half. And lastly, we have here square root of 3 all over 2 and negative 1 half. So that's it. I make it even quicker actually. But yeah, I think you get the point. Okay, I think you get the point here. Okay, so I actually speed run it actually, or I make it direct to the point. But yeah, now you know. So how about the angles? Okay, what if we're going to talk about angles and the coordinates itself, just like what we discussed from our previous videos. Okay, let me erase the other angles here. Okay, and other unnecessary writings here. All right, just give me for a second. Okay, so if you have an angle of 30 degrees, so you will have the coordinates of square root of 3 all over 2 and 1/2. That means if you have 30 degrees and other coterminal angles of it, you will have the coordinates of square root of 3 all over 2 and 1/2. Okay? Next, what if you rotate it even more until you reach this vertex? So from here to there, you will have this one. Okay? So here, you will not have an angle of 30 degrees, but rather you will have 150 degrees. So here, if you form an angle of 150 degrees, you will have a coordinates, or you will have coordinates of negative square root of 3 all over 2 and 1/2. Okay? Of course, I forgot the coterminal angles of 150 degrees. Now we go even further. Okay, we go even further. Like, what if we reach from here up to this point? So here you will not be having 150 degrees anymore, but rather 210 degrees. So if you reach 210 degrees and or other coterminal angles of 210 degrees, you will have the coordinates of negative square root of 3 all over 2 and 1/2. Okay? It's not 240, guys. It's actually 210 degrees. 210 degrees. Okay? Again, it's 210 degrees, not 240 degrees. Okay? And last but not the least, if we reach further, in which we reach up to the fourth quadrant, okay, until here, wait, until here, so you will have an angle of 330 degrees. So if you have an angle of 330 degrees and other coterminal angles of it, you will have the coordinates of square root of 3 all over 2 and negative 1/2. Oh, whoa, 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 this is wrong. Wait, this is wrong, bro. This is wrong. Okay, this is wrong. Okay, this is wrong. It's square root of 3 all over 2. Wait a minute. If that's the case, then okay. Anyways, it's positive, okay? Positive square root of 3 all over 2. Okay? So, wait, just for a second. I might be, wait. Let me just check. Never mind. They're all correct. Sorry, I have to double check. You get me? But yeah, they're all correct. Okay? So yeah, actually we're done. We're done discussing the unit circle, like the coordinates rather. So I suggest you should take a break for a while. Don't worry, we'll be back. Okay, like take a break for like a minute, 1 minute or 2 minutes, I guess, or at most 5 minutes. So 1 to 5 minutes, I suggest. Then after that, we're going to proceed to the summary of the overall, of the overall unit circle. Okay, so take a break. Pause this video for 1 to 5 minutes. Okay, so now that you took a break, let's now talk about the summary. So the summary, it looked like this. There you go. All right. So this is actually from, I mean, this picture is actually from this source or from this link. All right. So here, this is the unit circle. If your angle here is 0 degrees or any other coterminal angles of 0 degrees, such as 360, you will have 1, 0. Okay. If you have 30 degrees or pi all over 6 radians, or other coterminal angles of 30 degrees, you will have the coordinates of square root of 3 all over 2 and 1/2. Okay, and so on and so forth. But you see, I would like to what do you call this one? Describe something here. If you're going to notice, they're like mirrors. You get me? Like for example, 1, 0, then we have -1, 0 here. Square root of 3 all over 2, 1/2. They also have square root of 3 all over 2 and 1/2, but the x coordinates here are negative. We have square root of 2 all over 2, square root of 2 all over 2. On the left side, they also have they have square root of 2 all over 2, square root of 2 all over 2. But again, on the second quadrant, uh, the x coordinates are negative, okay? And lastly, 1/2 square root of 3 all over 2, we also have 1/2 square root of 3 all over 2. So you see what I mean here? They're like mirrors, you get me? They're like mirrors. So here, if ever like for example, you're confused, uh, like let's just say, what would be the coordinates of 150 degrees? Well, look at 30 degrees here, okay? Which is square root of 3 all over 2 and 1/2, okay? But 150 degrees is second quadrant. So that means the x coordinates are negative. Therefore, you will have negative square root of 3 all over 2 and 1/2 instead. So similarly, like in other example, if, for example, you're not sure what would be the coordinates of 120 degrees, well, look at its mirror, which is 60 degrees. So we have 1/2 square root of 3 all over 2. But 120 is on the left side or in the second quadrant. So we will have -1/2 and square root of 3 all over 2 instead. Okay? And the same thing if, the same thing in terms of, you know, reflection uh, across the x-axis. Okay, what I'm trying to imply here is that we reflected the coordinates here from left to right, and we can actually reflect the coordinates from up to down. Like this, for example, square root of 3 all over 2, 1/2. Here we also have square root of 3 all over 2, but it's -1/2 because it's in the fourth quadrant. Same thing here, square root of 2 all over 2, square root of 2 all over 2. We also have that one, but what? The y coordinates are negative here because it's the fourth quadrant. And last but not the least, this one is just a mirror to this one, okay? But signs only differ, okay? And the same thing, like across the x-axis, like if you're going to compare the other coordinates here, there's actually mirror to here, to here, and to here. But the signs only differ like this. -1/2 square root of 3 all over 2. Okay, it's a mirror to 240 degrees, which is also -1/2, but we have negative square root of 3 all over 2 instead. So you see my point here? There's like a mirror here. You get me? There's like a mirror here, and at the same time, they have like huge similarities due to their numbers. Like for example, let me erase everything. Like for example, we have square root of 2 all over 2 here. We also have square root of 2 all over 2, then square root of 2 all over 2, then square root of 2 all over 2. You get me? Then same thing here. We have square root of 3 all over 2, 1/2. We have negative square root of 3 all over 2 and 1/2, then here and here. Despite their signs, the numbers are the same. You know? And why is it that they're the same? Well, it happens because of, the drawing. Remember the drawing we made? The shapes, like we divide the circle by 4 congruent arcs. We imagine that what if we have a square? You get me? And what if we have a regular hexagon? So these are the results. Okay. Don't worry. There's like a technique I'll teach you because you're gonna memorize this one, whether you like it or not. You're gonna memorize this one. All right, whether you like it or not, because this would be applied on the next topic we're going to discuss, which is the right triangle trigonometry. So that's like the the part where we're going to talk about triangles, like literally. So you're gonna need to memorize this one. But don't worry, on the next topic, I'm going to teach you how to memorize it, like in an easy way. Okay. So if you want to memorize this now, then that's good. Okay. So yeah, going back. Okay, right? As I said, they're similar due to their numbers, like square root of 2, or square root of 2, square root of 2, like numerically they're the same, but the signs differ. So you see, 45 degrees, 135 degrees, what's next? 2 to 5 degrees, this one as well, you know, they result to having square root of 2 all over 2, but signs differ. And this happens because of the square, right? The square that we put here, right? And this happens because they both form 45 degrees. You get me? They both form 45 degrees. Wait. Yeah, 45 degrees, and 45 degrees here. Okay? So it seems like, yeah, 45 degrees here, 45 degrees there, they look the same. You get me? So what does this mean? It means that in each angle, and if you're going to compare to the other angle, there's actually what we call as the reference angles. And that reference angle will give you these values. Okay? But the signs will only differ. Okay? Again, the main reason why that these coordinates are the same due to their number but not their signs was because of reference angles. It was because of this one. Okay? Reference angles. Okay? And that would be our last topic that we're going to discuss in the unit circle. Reference angles. Okay? That is the reason why uh, this what I call that is the reason why if you're going to get the angle of 45 degrees, 135, 225, 315 degrees, the numbers are the same. Square root of 2 all over 2, square root of 2 all over 2, but the signs only differ. And again, it was due to the reference angles. So we will talk about that soon.